2.2, 2.3, covering functions, graphs, and domain and range. So first thing we're looking at is what is a function. A function is just a special relationship between two sets. We call the first set the domain, which is like your x's, starting point, independent variables. The second set we usually refer to as the range, which is your y values or your dependent variables. And the key to be a function is that in order to be a function, any member of the domain can have at most or exactly one member of the range to which it corresponds to. If they have that relationship, then we can define it as a function. All right, so example 1, determine whether correspondence is a function. We call it a correspondence because we don't know whether it is or not. So by definition, to be a function, each member of the domain has to have exactly one member of the range. So the member of the domain 8 has exactly one member of the range 2. The member of the domain 0 has one member of the range 17. And the member of the domain -5 has one member of the range 17. So what you want to be careful of is it doesn't matter that they both go to the same element in the range. It's that each domain goes to one in the range. So yes, this is a function. All right, example 2, doing the exact same thing. All right, determine whether the correspondence is a function. So if we look at this, the element, we know this is our domain because it's our starting point, and that means this is our range, it's our ending point. So if we look at this, Jackson has an element in the range of football and an element in the range of wrestling. So by definition of a function, each element in the domain can have exactly one member of the range. And right here, the element Jackson in the domain has two elements in the range. So we don't even need to look at the others. This is not a function. All right, so then there's your definition again, just to remind you. All right, so when we know something is a function, we tend to use special notations at times called function notation. So if we're looking at this here, f of x, if we look at example 3, calculate the output f of 3 for the function f of x equals 5x plus 2. So this right here is called function notation, and it is read f of x. F is probably the most common letter, but it could be g of x, k of x, q of x, anything of x. So think of the function notation f of x. It is just a fancy y value. So f of x is just a fancy label for a y value. All right, so we're asked to calculate the output f of 3. So if we look at the notation here, f of 3, this right here is telling us that the x value is 3. So what we're being asked is we're technically being asked to find, remember f is a fancy name for y if x is equal to 3. All right, so we were told f of x is 5x plus 2. I'm just going to copy it here. Plus 2, I think. Yes. So f of 3, remember, find y when x equals 3. So we're essentially just plugging in 3 for x and then simplifying. So when you substitute values in, I like to write out a template. So I'm going to do everywhere I've got an x, I'm going to create an open bubble. So I'm going to go 5, bubble, plus 2. And in that bubble goes the x value we were given of 3. And then we can go through and clean it up. All right, so f of 3 is going to be 5 times 3 is 15, and then 15 plus 2 is 17. So f of 3 is 17. All right, example 4. Find the indicated function value for each function. Use appropriate notation. All right, so we're doing the same thing we just did. All right, find f of negative 2 if f of x equals 3x squared plus 2x. So again, f of negative 2, what is y if x equals negative 2? All right, I get my template. F negative 2 equals 3 bubble squared plus 2 bubble. So even when you have more than one x, every x is going to get replaced. So this negative 2 is going to go in both places where the x was. All right. All right, order of operations, exponents first. Negative 2 quantity squared is 4. I can go ahead and simplify at the back. 2 times negative 2 is negative 4, plus negative 4 minus 4, whichever you prefer. All right, and then 3 times 4 is 12, and then 12 minus 4 is 8. So f of negative 2 is 8. So that means when x is negative 2, y is going to be 8. All right, next one. Find g of 4 if g of t equals 6t plus 9. So notice the change in the variable. We still treat this one here. This is still just like our x. All right, so g of 4, what is y when t equals 4? Get my template set up. 6 times a bubble plus 9. And in my bubble, is going to go my t value, which is 4. So g of 4, 6 times 4 is 24. And then we add 9. So g of 4 is 33. So when t is 4, the y value is 33. All right, C, find h of m plus 2 if h of x is 8x plus 1. So this one looks a little bit different. We're still being asked to sub in, so it's just subbing in a variable. So what we're being asked to plug in here is the quantity m plus 2. So anytime you're subbing in a variable, it is not going to usually simplify down to a single number. All right, let me get my setup. All right, h of m plus 2 is going to be 8. Make a little bit bigger bubble, plus 1. What I'm subbing in still goes in where x was. All right, order of operations. We need to distribute that 8, so the 8 goes to the m and to the 2. 8 times 2 is 16. Then we can combine like terms. Only like terms are the 16 and the 1, which would give us 17. All right, we can do the same idea when we're looking at graphs. So what we're doing is being asked to graph this function here. All right, so we will cover quadratics later on down the road. For now, as far as graphing goes, we want to make sure we get our points plugged in correctly. So keys is knowing what the shape is going to be. So this exponent of a 2 right here is telling us that this is going to be what's called a parabola. And there's 2 ways the parabolas can work. They can either, most of them for now, will go open upward, but they can open downward. Come on, give me a pretty parabola. Third try is always the best. Got it. Okay. But the key in graphing a parabola is it takes 3 points. We need 1, we need the vertex, and then we need a point to the left and a point to the right. Even if it opens downward, we still need the vertex and a point to the left and a point to the right. So for now, these parabolas are going to be centered on the y-axis, which means we want to plug in 0 for x first. Okay? All right, so first thing I'm going to do is I'm going to choose x equals 0. So if I choose x equals 0, that means I need to find y when x equals 0, or in other words, I need to find f of 0. All right, get my template, bubble squared minus 1. And in my bubble goes 0. All right, so f of 0, 0 squared is 0. 0 minus 1 is negative 1. All right, so because we're not just asked to find this value, we are asked to put a graph in place. We want to write this as an ordered pair. Remember, your ordered pairs are x comma y. So the ordered pair associated with x equals 0 is going to be 0 comma negative 1. All right, I'm going to get my second point. I need something to the left. So I tend to just ooch over 1. So I'm going to ooch over to negative 1. So now we're going to calculate f of negative 1. So bubble squared minus 1. So just plugging in a different x to our same function. And inside my bubble goes negative 1. All right, f of negative 1. Negative 1 quantity squared is 1. 1 minus 1 is 0. So our second point, x, negative 1, comma, y, 0. All right, my third point. We went to the left of 0. Now we want to go to the right of 0. I'm going to go to 1. All right, f of 1. Get my template, bubble squared minus 1, this time subbing in positive 1. All right, 1 squared is 1. And then 1 minus 1 is 0. So my second point, x comma y, is going to be 1 comma 0. I guess my third point. All right, so I have my 3 points. So as far as a graph goes, x axis runs left and right. Y axis, or you could say f of x axis, runs up and down. So to plot my first point, 0, negative 1, 0 means I don't go anywhere on the x-axis. Negative 1 means I go down 1 on the y-axis. So there's my first point. Second point, negative 1 comma 0. Negative 1, I go left on the x-axis. 0, I don't go anywhere for the y-axis. Third point, 1 comma 0, I go out to 1 on the x-axis, and I don't go anywhere on the y-axis. So then I can see that parabola shape, and then I'm going to play connect the dots. Well, I'm going to try. There we go. And close enough. All right. All right, so we've graphed functions, we've calculated function values, we've determined if a correspondence is a function using those sets. Now we're going to look visually, well, how do we know if a given graph is or is not a function? So when you're given a graph, the key for determining whether said graph represents a function is called the vertical line test. So when trying to determine a function visually, a vertical line is not allowed to cross the graph more than once, because that goes back to that each element in the domain is allowed exactly one member of the range. If it hits more than once, it's going to have more than one member in the range, which means it's not a function, or we could say it fails the vertical line test. All right, example 6, determine whether each is the graph of a function. So this one's got the vertical line drawn in for you, but another way, I'm just going to pass my vertical line across it so we can see. So I'm good here, but the second I run into this portion of this graph, I wind up intersecting that vertical line more than once, which tells me this cannot be a function. So this is not the graph of a function. All right, second one, I'm going to drag my vertical line over. All right, if I start at the edge, we're good, we're only hitting one time. I go all the way across my graph, and each time I only intersect this vertical line once, which tells me that this is the graph of a function. because it does pass the vertical line test. Third one, got my graph going. Whoops, that wasn't my drag tool. All right, good right here, but then I come in here. The second we hit more than once, we're done. It is not a function, also known as a lightning bolt. All right, so we've already mentioned that when we have a function, we call the x values or independent values the domain, which is your first value, and then the set of the range is referred to as the y values or the dependent values. All right, so here we are asked to find the domain and range of the function who's graphed below. So a couple ways you can be given a function is, in this case, it's just kind of like a bunch of scattered points. So when we're looking for domain and range and all we have are fixed points, we're just going to list them in what's called a set. So easiest way to list them in a set is first thing I'm going to go across and write out what these ordered pairs are so that the x and y values are easier to see. So this first coordinate right here, remember x comes first. We went out to -5. Remember, this is your x-axis. And then we went up to 1 on the y-axis. So this is the point -5, 1. This second point here, since I can see this one, we went out to 1 on the x-axis. We didn't go up or down. We're still on the x-axis, so we did not go anywhere, so 0 on the y-axis. Third point up here, we went out to 4 on the x and up to 3 on the y. And then this hidden one down here, we went out to 3 on x and down to -5 on y. All right, so I have my points listed. So my domain is the set of x's. I tend to just use a D and a colon. We want to write it in set notation. So I'm going to go open squiggle, like a curly brace, and then just list my x values separated by a comma. So -5 is my first x, comma, then we hit 1, then we hit 3, and then we hit 4. And then I'm going to close my squiggle or close my set. So there's my domain. All right, for my range, I'm going to use a capital R with a colon, open squiggle. Now I'm listing the y values. So smallest y, first one we hit was -5. Then we moved up, we hit 0. Then we hit 1. And finally we hit 3. And I'm going to close my squiggle. So when it's a bunch of points, you just list the elements of all the x's separated by commas in curly braces for your domain. List all the y values in a set of curly braces separated by commas for your range. All right. Here, we still have the graph of a function. We know it's a function because 1, we're told here. 2, it's got that function label on the graph. It also passes the vertical line test. So we're asked a couple things. So let's see, the number in the range that is paired with -2 from the domain. So then it says that is find f of -2. So there's 2 ways you can be asked this. One is that first sentence, find the number in the range. When it says find the number in the range, that means find y. When paired with -2 from the domain. So this right here is telling us x is -2. Usually you will not see this written both ways, so you could either see that first sentence or you could just be asked, what is f of -2? Okay? So f of -2 means what is y when x equals -2? So f of -2 is, all right, so we know x is -2, so the easiest way to figure that out is to go locate -2. Here is where x is equal to -2. Okay. And what we're looking for is where our graph intersects the x value -2. So if we look at our graph, right here is where the 2 meet. So that means when x is -2, f, which is the fancy name for y, is going to be 3. Where is it? There we go. So f of -2 is 3. All right, B, we are asked for the domain. Remember, the domain means the x values. So we're looking for the x values. All right, so difference here is this is not a set of points. This is a fully connected graph. So what we're going to do is we're actually going to write our answer two ways. What I need to do is I need to locate the smallest x value and the largest x value my graph hits. So x-axis runs left and right. So if I go to the leftmost end of my graph, we hit -5. That closed circle means it's included. So we hit, whoa. So we hit x equals -5. Do this one in pink. And it is included because it's a closed circle. We hit everything in between, so all the way up. And then I'm going to the biggest x value our graph hits, or where it stops here. Put a gap in there, which is at 3. So we also go to x equals 3. That's a highlighter. And it is also included because we have a closed circle. Okay? All right, so as far as writing our domain, I'm going to write it right here for now. So there's two ways you can write the domain. First way we're going to write it is we're going to write it in set notation, which is that squiggle, the curly brace. So if I put my squiggle this time, because we're not just listing x values, because we have a range, a whole bunch of x values that we hit, we're going to start with x such that, and then we're going to use an inequality. So the smallest x value we hit is -5. And because it's included means it's allowed to equal. So we're going to put a bar underneath. Anytime you have a closed circle, you're going to use a bar. But then because we have a stopping point, I'm going to put that symbol again. We stopped at 3. It was the biggest y value we're allowed to hit, and it is also a closed circle. So it is also going to get a bar. Anytime you've got a closed circle, you're going to use a bar. And then we close it. So I'm going to close my squiggle. So this is set notation. So the way that is read is it's the set of all x. That little vertical line means such that x is greater than or equal to -5 and less than or equal to 3. All right, second way we can write this notation is called interval. So interval notation still's got that D to show it's the domain. Interval uses parentheses or brackets to represent that inequality. So it's just changing that inequality in the set notation over to an interval. So the lower value goes on the left, the upper value goes on the right. When you have a bar underneath, a bar on an inequality or a closed circle translates to a bracket. So a bar means a bracket. So I'm going to bracket the -5, bar also on the 3, so I'm going to bracket the 3. This right here means the exact same thing as that inequality. It's just a different notation that we can use. Right, so there is our domain. And you know what? Because I didn't leave a whole lot of space in there like I should have, I'm going to leave the domain over here. All right, C. Actually, we'll go back. Let me label it B so we know that this goes with the answer for B. All right, C, we're looking for the number in the domain that is paired with, that should not be, let's see, 3. Yeah, that should not be a 6. Little typo there. Let's fix that. Go get, actually this, we're going to go pretend, magic erase. Those need to match. Kind of hard to answer it when they don't match. Okay, now it works. All right. Find the number in the domain. So notice we changed here. Number in the domain. So that means we're finding x. So we're looking for x that is paired with 3 in the range. So 3 in the range, what that's telling us is y is 3. Remember, y is a fancy, the fancy name for y is f of x. So in other words, find when f of x equals 3. So this time what we're looking for is all x's where y is 3. So that's what we're looking for now. All right, so if I go to my graph, y equals 3. Y equals 3 is going to be a horizontal line. So everywhere along this horizontal line is where y is equal to 3. So if I look at my graph, where my function and my y value of 3 intersect is here. However, it is also here. So I have 2 places. Okay? So our solutions are going to be x equals -2 and x equals 0. So we have 2 here. So x equals -2, we'll just list it below, comma, actually I said -2, comma 0. So we had 2 places here. So when you're looking for the x values, it is possible to have more than one. When you're looking for the y values, you can only have one. Okay, so this is C. All right, D, the range. So the range means all the y values. Let me use another color since I've got all kinds of colors going on. All right, so we're going to do our range down here. All right, so just like we did with domain, there are 2 ways to do it. We'll do it in set first, and then we'll do it in interval. All right, that's an R. All right, so now we're looking at the y value. So I need the smallest y. So we're moving from the bottom to the top. So here's my y-axis, and I'm going to start moving up. So I want to find the smallest y that hits my graph. So if I move up, 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 right here, I hit my graph. So notice it wasn't necessarily at the end, it was right here. So it looks like the smallest y we get to is -1. And then I'm going to continue moving up. So if I keep moving up, we hit all these y's, all these y's. It looks like the largest y we get to is 7. All right, so smallest y, -1, graph hits it, so it's included. Largest y is 7 with a closed circle, so it is also included. So for our range, we're going to open squiggle, y such that, if you want to put f of x such that, you can. It's up to you. -1 less than or equal to y less than or equal to 7. So there's our set notation for our range. All right, interval notation, smallest value left, biggest value right. -1 has a bar, bar means a bracket. 7 is also included, or it has a bar, bar means bracket. So there is our range in both notations. All right, so there's our visual aspect of the domain and range. Last thing we look at is the domain algebraically. We're not going to do the range algebraically. Right now we will deal with some range later on when we're given functions. So as far as domains go, these are the most important things you want to remember about an algebraic domain. There are 3 things that you are not allowed to do. Okay? You are not allowed to divide by 0. So if we cannot divide by 0, what that translates to as far as what we're worried about, division means we have a denominator. A denominator is not allowed to equal 0. So when something's not allowed to equal, we just do an equal sign with a slash. So a denominator is not allowed to equal 0. That's going to be the most common one that we deal with. Second thing you're not allowed to do is to take the square root. I did put even root in parentheses because it works the same if it's a 4th root, but square root's the most common one. We cannot take the square root of a negative number. So what that translates to is if I have a square root, the stuff under that square root, I'm just going to call it stuff. It's technically called the radicand, but stuff works too. That stuff that is up under your square root cannot be negative, which means it must be greater than or equal to 0. And then the last thing, which we're not going to have to worry about until we get to the last chapter, we cannot take the log of 0 or a negative number. So a log, there's 2 types of logs you'll see, either log or ln. We'll worry about ln later. So, and then you're going to have some stuff inside that log. Technical name's called the argument. We'll just call it stuff. It's easy. So because we cannot log 0 or a negative, what that translates to is that stuff or argument that is inside of your log is strictly greater than 0. Strictly greater than 0 means it cannot equal, so we have to omit the bar on the inequality. So those are the only 3 things that there is an issue with in the domain. If the function you're given has none of these things, then what that means is it has no restriction on its denominator, or in other words, its domain is all real numbers. So if it has none of these, it has an all real number domain. An all real number domain can be written in a variety of ways, and when we run into one of those, we'll go over that. All right. All right, so domains, it says find the domain of each function. You may write your interval in set, or you may write your answer in set or interval notation. So just be careful with the homework. Make sure you put it in the correct notation. All right, so first function here, basically what we want to do is just go through each restriction one at a time and see what we run into. So first restriction is denominators cannot equal 0. If I look at this function, I have a denominator. So this is my denominator. As far as domains go, a denominator cannot equal 0. So what I do is I take everything in my denominator and say that it is not allowed to equal 0. So everything in my denominator is x minus 8. So x minus 8 cannot equal 0. And then we solve for x. So solving a not equal to is just like solving an equal to. I've got to get x by itself. So the 8 needs to be moved. So to undo subtraction, we're going to add 8 to both sides. So if I add 8 to both sides, I get x cannot equal 8. All right, so as far as writing my domain out, I have my restriction. It means we can equal all x except the number 8. So now I'm going to go write it. We're going to write it in both notations for practice. So here's my set answer. So open squiggle, x such that, rather than listing an inequality here for set, we can simply just say x cannot equal 8. And then it's implied that x is any number except 8. All right, for the interval notation. All right, so we can be on any number except 8. That means I can go all the way down to negative infinity, and I can go all the way up to positive infinity. So my lowest, I got to have a cutoff, lower bound, is going to be negative infinity. My upper bound is going to be positive infinity. Anytime you use an infinity symbol, be it negative infinity or positive infinity, you use parentheses. You have to use parentheses. Never bracket your infinities. All right. The only thing we're not allowed to be on is 8. So what we're going to do is just basically take this interval and jump over the number 8. So rather than have one interval, I've got to have 2. So we're going to stop at the number 8. We're going to say we can't be on it. So when it's excluded, we use a parenthesis. We're going to build a new interval. Anytime we have multiple intervals, we use this symbol. It looks like a U. This U right here, it means or. So I can be in one or the other. And then I pick it right back up at 8 and continue on to infinity. So basically, we're just going to jump over the number 8. And as far as an open-ended question on a test, I will take either answer. Just be careful with my math lab. If they want a specific notation, make sure you answer in specific notation. All right, next one. Let's put a little break here. All right, go through one condition at a time. So our function is f of x equals 3x cubed plus 2. All right, if I look at this function, denominator. It does not have a denominator, which means I don't have to worry about anything not equal to 0. Second thing is an even root. An even root is a square root. Remember, that square root looks like that check symbol, and it either doesn't have a number or it's got an even number here. I do not have one of those. Log. Like I said, we're not worried about logs until chapter 9, but I do like you to go ahead and ask yourself, does it have a log? No. So we said no denominator, no even root, no log. If you say no, 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 you have no problem, which means no restriction. If you have no restriction, that means you have an all real number domain. So an all real number domain can also be written a couple of ways. So as far as the set for all real numbers, I like to use what's called the double bar R. That does mean the set of all real numbers. My math lab usually will just have you choose the bullet point all real numbers. A lot of you were taught to fully write it out, the set of x such that XER. I'm good with that too. If you just write all real numbers, the set of all real numbers, I'm fine with that as well. For interval, the interval for all real numbers means there's no restriction. So we start at negative infinity. We never include symbols, so parenthesis, and we just continue to positive infinity, also with a parenthesis. Make sure your negative infinity is on the left side. All right, next. All right, function -2 divided by the quantity 3x plus 1. So first question, do we have a denominator? The answer is yes. So we have a problem, possibly. My denominator is not allowed to equal 0, so I pull everything in my denominator and say you cannot equal 0. All right, we need to solve for x. So undo what is not attached first. So addition and subtraction gets moved first. So I'm going to subtract 1 from both sides. Then I am going to divide by 3. So that tells me x cannot equal -1 divided by 3 doesn't divide nicely, nor does the fraction reduce. Leave it as a fraction. All right, answer. So set domain, I'm just going to put an S. Open squiggle, x such that, copy paste, x cannot equal -1/3. Close squiggle. So that means we can be any real number except -1/3. All right, interval. So I can start at negative infinity. I can continue to positive infinity, but I got to jump over -1/3. So I'm going to stop and I'm going to jump -1/3, union, and continue on the other side and jump over it. All right, and D, I think it's the last one, yes. All right, one question at a time. Denominator. Function is f of x equals -7x minus 1. There is no denominator, okay? Even if, so just kind of a note, even if there was a division like -7/3, this doesn't have an x in a denominator, it's just a 3. So not an issue. All right, no denominator. Even root, square root, I don't see a square root. Log, I do not see a log. Like I told you, that's a whole separate chapter, so I said no denominator, no square root, no log, no means no restriction, all real number domain. So domain, double bar R, or if you want to write the set of all real numbers, perfectly fine, or the interval, negative to positive infinity, always with parentheses on your infinities. If you do brackets, they are wrong, so be careful with that. Cannot include a symbol. So parentheses always. All right. Done. Think. Yes, the rest are you try it. So if you want to try those and check them with the completed notes, feel free to do so.